Cosmology is the way that a people view themselves in relation to the rest of the universe. It's the way that they assign meaning to the celestial events that they see in the world around them and how they interpret the universe. So, one of the most common ways that we can think of cosmology is as it relates to astrology, astronomy, constellations. So, looking at the stars, connecting the dots, creating images, and assigning meaning to those images. So, for example, if we look here at this shot of the night sky, we see the brightest star is located here. This is the star that the Dogon call Putulu. Is a star, actually a star system. It's two stars, a brighter star, the one that we see, and there's a smaller star that's actually an older star that's more dense. And the Dogon call that star, that smaller, more dense star, they call it Putulu. And they consider that to be the star of deep beginnings because they see the origin of human beings, the origin of our species as relating to coming from this star of deep beginnings. So we see the cosmology there in understanding that a relationship to astronomy. We can also see that these three stars are also very common stars that you all probably have noticed if you ever looked into the night sky, that these three are what we use to point towards this star that the Dogon call Hutsulu. These three stars are also very important in African cosmology. We can go back to the Nile Valley, to the African Nile Valley, and where these three stars were part of a constellation to the neter known as Sahu. And Sahu is a neter, and his wife was associated with this particular star. So the Dogon called the star Putulu, but to the Africans of the Nile Valley, this star was known as Spitit or Suptit. All right. And this is how their cosmology unfolded. Okay, change orientations here a little bit, but we still have, this is the same three stars that we were looking at before and pointing to this star that the Africans of the Nile Valley called Spitit. So this was Sahu. Sahu is known as the hidden one. His wife Spitit, she was known as the skilled woman. And they were a very important component of Nile Valley cosmology. Their son was named Sopdu, and Sopdu was associated with the sun, also associated with the planet Venus. So you have Sahu, Spitit, and Sopdu being very much analogous to Asar, Aset, and Heru, right? Because Sahu was very much like Asar. Sahu was seen to be defeated by the forces of the underworld at dawn when the sun came up, and he was resurrected every night, of course, when the stars came out and we saw this constellation. Likewise, Spitit, his wife, was useful. This particular star was used in predicting the annual inundation or the flooding of the Nile River. So this star will disappear for about 70 days just before that annual inundation. So this particular cosmology was very, very important in Nile Valley in terms of managing time, in terms of for their agricultural purposes and so on and so forth. And we see that connection when we talk about as above, so below so much in African mathematics. This is literally where that comes from. We see that the three stars that make up the belt of Sahu are perfectly aligned to the great pyramids of Giza. So pyramid of Khufu, Khafra, and Menkaura are perfectly aligned to these stars. So we see that this was the idea of creating as above, so below, the idea of creating a celestial paradise or so-called heaven on earth. So we have the stars of the Sahu's belt in the pyramids, and then we have the Nile River of the earth, which is the great river for the Africans in the Nile Valley, and we have the Nile of the sky, which is the Milky Way. So we see cosmology is a very, very important aspect for culture, but we can also see how it relates to geometry. So we've talked before about points, lines, segment, and rays, and we can think about constellations as simply a collection of points and segments. If we think of the stars as being points, we can think of the imaginary lines that we use to connect the stars as segments. And so this is the constellation of Sahu that we were just looking at in the previous image. And what we've done here is we have labeled the stars, which are now points, in order to express the various angles that we perceive between the various stars in the constellation. So we can take that cosmology and we can analyze it from a geometric perspective. So the first thing that we can look at are the various angles. So the first angle I want to look at is the angle right here, this angle right here, all right? And this angle, I would name it angle IKJ, all right? So geometrically, I would write it as angle IKJ. And if we look at this angle, we can tell by just looking at it without actually measuring it that it is an acute angle, that it is less than 90 degrees, okay? So this is an acute angle. Now we can also look at another angle, angle AHC. So that's going to be here. Right? So this is angle AHC, and we can look at angle AHC, and just by looking at it, we can determine that this is an obtuse angle. All right? It's an obtuse angle because it is greater than 90 degrees, but it is less than 180 degrees. All right? So this is angle AHC, and this is obtuse. And by the way, we could also name this angle a few other ways. We could also name it angle CHA. All right, so we can go this way and call it angle CHA, or we could also name it, in this case, we could also name it angle H. All right, the key here is that in both of these, with the 3 points, the H, which is what we call the vertex, all right, this is the vertex. The vertex is in the middle. So if it's AHC, the vertex H is in the middle. If it's CHA, the vertex H is in the middle. In this case, we can simply call this angle H because this is the only angle that you could possibly create with this particular vertex. All right. If we look at the angle, so these all go together. All right. So these are all the same angle. But if we look at angle IKJ, we could also name it angle JKI, but we cannot name it angle K. Why can't we just name it angle K? The reason we can't name it angle K is because there is ambiguity there. That angle K could be angle IKJ, or angle K could be angle JKL, or angle K could be angle IKL, right? These are all different angles. So we can't just name this angle angle K because there are adjacent angles associated with this particular angle, and so therefore we can't do it. All right, so that's a obtuse angle. Another angle I want to look at is angle LAH. So angle LAH is here. And I'm going to give that 2 marks because that may or may not be the same angle here. So let's just assume to be safe that it's different. So this is angle LAH. And looking at it, it looks to be very close. It is almost a right angle. I would say it is actually a little bit obtuse. It looks like it's going just a little bit past 90 degrees here. So I would call angle LAH, or angle, you can call it also angle HAL. I would call this an obtuse angle as well. Another angle we can look at, angle HCO, also known as angle OCH. So that's this angle here, right? And looking at this angle, we can tell that this is also an obtuse angle, right? So the way that we classify angles, and we've talked about this before, of course, but we've classified them as acute, and acute angles are less than 90 degrees. We classify them as obtuse. These are angles between 90 degrees and 180 degrees, so less than 180 degrees, but greater than 90 degrees. We have right angles, and right angles are equal to 90 degrees. And then we have straight angles. And straight angles are equal to 180 degrees, and they make straight lines. All right? And finally, we can measure angles using this device known as a protractor. And the way a protractor works is you choose one of the rays of the angle and you align the straight part of the protractor with that ray. So here we've chosen this ray here, and we've overlapped. There's usually a hole here, and we overlap the vertex of the angle with the hole, and we make sure that this straight edge, the straight part of our protractor is aligned with one of the rays. And once this straight part is aligned, we read the angle measure off of the from the other ray. So the other ray here, we see that it seems to be between 40 and 50 degrees. So we can say that this one is a 45-degree angle. And of course, we can also measure obtuse angles in the same way. So we align one ray with the base of the protractor, with the horizontal part, the flat part of the protractor, the straight part of the protractor, and then we read the angle from the other part. So here we have an obtuse angle, and we know it's obtuse because we can see that the measure seems to be between 130 degrees and 140, so we can measure this one at about 135 degrees. All right, so that is how we name, measure, and classify angles.